In this video, we're going to talk about the third data transformations method, which is the reduce method. And as you remember, we used the reduce method to essentially boil down all the elements in an array to one single value. And we talked about the example of adding up all the numbers in one array, right? And so let's try that now with our movements array. And remember that array looks like this, okay? And then by adding up all these numbers, so both the deposits and the withdrawals, we end up with the global balance of the account, basically. So let's start using the reduce method here. And so as I just said, we're gonna call it on the movements array. And the result of the reduce method will be, as I just said, the global balance of the account. So let's call the result balance. And remember that in this case, this balance will be simply one value and not an entire array. Okay, so the reduce function also gets a callback function, but this one is a little bit different from the other ones, like the one in map or for each. So in these other callbacks, the first parameter is always the current element of the array. Let's call it current. The second one is the current index, and the third one is the entire array. But here in the callback function of the reduce method, the first parameter is actually something called the accumulator. So let's call it ACC like this as an abbreviation of accumulator. And this accumulator is essentially like a snowball that keeps accumulating the value that we ultimately want to return. So in the case of adding all the elements or all the numbers of an array together, that will be the sum. So let me write that here. Oops. So let me write accumulator is like a snowball. All right. But anyway, let's now write the actual function block here. So as always, this callback function here will be called in each iteration of looping over the array. So reduce also loops over the array and calls this callback in each iteration. But now, what will we actually do in each of these iterations? Well, since the accumulator is the value that we will keep adding to, what we're going to do here is to add the current value to the accumulator. So the accumulator plus the current value. Okay? And this works because in each call of the callback function, the accumulator will be the current sum of all the previous values. And so we will really keep adding to this accumulator in each iteration of the loop. Finally, we also need to return this value here from the callback. And so this is how the new accumulator can then be used in the next iteration of the loop. So basically, in each loop iteration, we return the updated accumulator, so the current one plus the new current value. And so like this, we can then keep adding to it in the next iteration. Okay? So this callback function is the first argument of the reduce method, but the reduce method actually has another, so a second parameter. And that is the initial value of the accumulator. So the value that we specify here, which in this case is going to be 0, is the initial value of the accumulator in the first loop iteration. And so in this example, we want to start counting, or we want to start adding at 0. And so therefore, we simply specify 0 here. Okay, and with this, we should be able to already take a look at our balance. And yeah, so we have one single number. So indeed, everything was reduced, was boiled down to this one number, which we can suppose is all of these values here added together. All right. And to make this even more clear to see, let's actually always log the accumulator to the console. So let's say iteration number I, and then the accumulator in there. Okay, so we see that in iteration 0, the accumulator is 0. And so this is the value that we specified here as the starter, so as the initial value. Then in the second iteration, the accumulator is already at 200. And that's because that is the initial value plus the current value in the previous iteration. So that was 200 there, right? And so this 0 plus the 200 creates the new accumulator, which is then in the next iteration 200. Then in this iteration, we add the current value again, which is 450. So that result is 650. And therefore, in the next iteration, that's the value of the accumulator. Okay? And so here you can really see like the snowball effect of all of these values adding up to one final value. And in the end, that value is essentially the accumulator. Now here we see the value going down because in this iteration we are adding minus 400. And so 250 is 650 minus 400. Okay, so in the last iteration, the value is 2540, and then adding 1300 will eventually result in this value here. Great. So this is really how the reduce method works. And I think this log here is a great visualization of that. Let's give it all the space we need. And let me just change this one here to 100 so that you see the effect of changing this. And so now we can expect this accumulator in the beginning being 100. And so we already start with a small snowball here, which then we keep adding to. And therefore, our final balance is now 100 euros, or whatever it is, larger. Okay? And yeah, let's one more time do the same thing manually, basically with a for loop. So of movements. And so we need one more time an external variable here, which is going to be the sum. Let's call it balance 2. So balance 2 starts at 0. And so essentially this is our initial accumulator value, just like this 0. And then sum plus equal the current movement. And if we log balance 2, we will get, okay, of course, this has to be balance 2. But now we get indeed the same result. And so here you can see this common pattern that we always need an external variable whenever we want to use a for loop. And that's fine if you only need one loop, but it starts to become really cumbersome and unpractical when we use many loops for doing many operations. So these methods that we've been studying, they completely avoid this extra variable, and they simply return the variable or the value actually right away. All right. And of course, we can write this here in an even simpler way. So using an arrow function, and I will still keep this here so that we can see the return that's happening. So first we can get rid of this. Then we get rid of this. We also don't need any of these. But here we always use or need the accumulator and the current value. So here we need parentheses, then the arrow, and then, as always, we can get rid of all of this. And so now still our balance is the same. Awesome. So understanding how the reduce method works is something really important, but it's also way more confusing than the other ones. But I'm sure you're well underway of really understanding it. And now that we know how it works, we can actually now also calculate the balance of these movements here, and then print that balance right here to our application user interface. And so let's go ahead and do that here. So finally back to our application here. And so let's do that down here. So calc and print balance. And so this function here will once again receive the movements as an input. So any array of movements will work. And so now let's calculate the balance based on this array. And essentially this is exactly what we wrote before. So that's movement dot reduce, but it doesn't hurt to write it here again. So remember, the first parameter is now the accumulator, and only the second one is the current value. So let's call it the movement now. And so here simply we return the accumulator plus the current movement, and we start at 0. Great. And now all we need to do is to display it here in this element. So let's check this out. And it is called the balance value. And just like before, I already have it selected here. And this is a label. So balance value is here. So I called it label balance. And so label is basically all the things where we simply want to put some text in. All right. So let's say label balance dot text content, and this one we already know, equals the balance. And let's actually do a template string here, or a template literal, and also display the euro sign. Well, I don't know where it is, so let's just write EUR, which also means euro. And so now, let's see. Of course, we didn't call the function yet. So let's do that here as well. And actually, let's put this function here where it makes a little bit more sense, because it kind of belongs to this display movements here. Okay, so let's actually also call this one here calc and display balance. So to give it a similar name as that one. And so now I'm going to call it calc display balance. And once again, I'm calling it with account 1. So account 1 dot movements. And then later on, as we keep developing this application, of course, these movements here that we're going to use will be from the account that logged into the application. So if Jonas logged into the application, then Jonas's movements will be shown and Jonas's balance. But if Steven logs in, then of course Steven's movements and Steven's balance will be shown here. And right now we already see our balance up here. And so this actually happens to be exactly the same we calculated before. So also 3840, because the movements are indeed also exactly the same. Great. So that's beautiful. With this, we actually already completed some parts here of our flowchart. So let's also keep this one handy here so that we can keep looking at it. And so we already did calculating the balance and displaying the balance. So we did all this in just one function. And we also already have displaying the movements. So indeed, we are making some nice progress here. And the rest that you see here will be even easier as we go on. Now, just to finish this lecture here about reduce, let me show you one final example, because we can also do other stuff than just adding up values. That would become boring at some point, right? And so we can also do other stuff. So this time what I want to do is to get the maximum value of the movements array here. Okay, so in this case, the result we're looking for is this 3000. Okay, and so for that, we can also use reduce, because remember, reduce